Okay, what is exactly the problem? I think in testing, since you can't study that at a university, there is no software testing master's degree so far. There are a couple of universities in the US that offer in-depth testing knowledge at the university level, but overall it's quite thinly spread. So basically, you need to self-learn how to become a tester. There are several entry points into testing. One is development, so you come from development, you get bored in building things, you'd like to offer constructive criticism to products. So that's one way. The other way is just doing something else and falling into testing and doing that. When I talk about the conceptual model, what I perceive in the testing world is that there's a very simplistic way of thinking about testing. It's basically, well, just check that it works. There's no big thing about that, so what's the big deal? Now this has led to that there are not that many very good testers around. So how can we solve that problem? One way to do it is to look for anti-patterns in testing. What are these patterns that are very widespread in the testing world, but which are not really helpful? A good friend of mine maintains a large not to-do list. So it's the opposite of a to-do list. It's the things that you write down of which you consciously decide not to do. And sometimes in testing it's also a good idea to be aware of things that are not very helpful and just kind of put them on the not to-do list and not do them. So in the absence of any good educational means in testing, certification is something that has been offered by many companies. Now that often works like that you memorize a whole bunch of words and then you have multiple choice and you make the right crosses at these places. Now just imagine the same model for, say, airline pilots. So they go to a 3-day course, then they learn what a wing is and how many wings there are on the plane, and then they get a questionnaire, how many wings are there on the plane, and then they have 1, 2, 3, 4. And, it's actually a tricky question, are there 4 wings or are there 2 wings? What are the things called in the back? So maybe there are even 2 answers. Or just imagine a medical doctor, a surgeon, does a 3-day course, then has multiple choice. What's the heart for? What's the function of the heart? And then again, you have to cross something. And then they pass the test and they go into the hospital and make an open heart surgery. That is nonsensical. So why should that be for testers? One reason for that is it's a very good business model. Basically, you get everything in the box handed to you, and you can make a lot of money of it. So the courses are expensive. I'm not sure how expensive the courses are here, but in Switzerland, the course is about 4,000 euros, and then you have to pay an extra fee for the exam. So it scales a lot, but it's not really helpful, especially because certifications do not handle testing as a skill, but they handle testing as memorizations of specific phrases and words, based on a model that's 40 years old and that didn't work 40 years back, and why should it work today? So the same bunch of people that came up with the certifications built a standard. So a standard is a good thing. So standards that has the ISO stamp on it. It's a Swiss organization. It's a very reputable organization. ISO standard. It's got an impressively long number, and you think that's a good thing to do. Now, that is a big confusion there. Standardization can be a good thing in certain areas, and it can be very harmful in others. And the classification, as I see it, is that it is very helpful in systems that get harm from variation. So let's say if battery sizes were not standardized, and you would have 3 million different battery sizes, you probably wouldn't find the battery for your device anywhere. So that's a system that harms from variation, that receives harm. But there are systems that gain from variation, and testing certainly is one of these areas. The more variety you can inject into testing, the better it is. And if you try to standardize that, you dumb it down, and you're very likely to not catch the important things. This is one thing I observe very often at client sites as well. They have an erotic fixation towards their documents, this kind of this deep love for these thick documents. Now that again, that's not testing. This is just a helpful tool that can be useful in specific setups, but it's not the testing itself. So producing a test report, when you spend time in producing a test report, you're actually not testing. That's not what you do then. You're typing text on a piece of paper. So the secondary work products shouldn't be in the center of your activities. If you classify your testing work into various setups, various categories. One could be setup, the other one is really testing, and then there is the investigation and bug reporting. And so the setup, with writing text or kind of configuring your test environments, you should reduce that time as much as possible and maximize the time for testing. The more you interact with the product you're testing, the more valuable information you're gathering about your subject. Cool. Automate everything. So who would like to have 100% automation testing? All right. Okay. Good, good. Some more, maybe? Good. Yeah, up there, a couple. So, all right, let's do that with a very simple product. So, because I don't know how PowerPoint really works, let's go to a little bit more analog way. So that's a 2, that's a plus, that's an equal sign. So this is a calculator, and because we're a modern company, we work with minimum viable products, so we think we need to go out to the market and test our product as fast as possible. And so we just implemented 2 plus 2, and we go out to the market and see whether or not that is something that has business value, or something that our customers really want, and we think it's a cool thing. So, now question to you. You hold this thing in your hand, then you press 2 plus 2 and the equal sign. What is your expectation of what happens on the screen here?
2 plus.
Equals, what is displayed on the, what is displayed here?
2 plus 2.
No, 2 plus 2, and then you press the equal sign, and then?
And then it says equals and 4.
And 4, okay? Do we all agree that this is what happened? Okay, you just acted like computers and machines and not like humans. Because if you had acted like humans, you would have noticed that we haven't switched it on yet. And actually, it's visible here, so there's nothing on the screen. So it's quite obvious there is nothing here. But okay, so I'm not going to trick you anymore. So let's switch it on. And then usually there is a 0. That would be a reasonable expectation. So now it's switched on, everything. So let's put everything into the set of things we expect from that. So it is infinitely driven with power, so there's a battery that lasts forever. It's switched on, and the only thing we need to test is whether or not 2 plus 2 equals results in the same thing. The only sequence that you're allowed to do is 2 plus 2 equals, and then you can press a C to reset the display. So that's the only thing. Everything else is out of scope. So as you can see, there are no other buttons, so we test that. So let's automate the whole thing completely. What would be your first test?
Press 2.
Press 2, yeah. What's your expectation? 2 on the display. I just make it like this, so that's your expectation. Then you press what? Plus. Yeah, what's your expectation when you do that? So probably 2 is still displayed, but maybe quickly flickers to acknowledge that you press the button, right? Okay. And then you press 2, yeah. And then you still expect that there is a 2 here. Then you press the equal sign. You expect a 4. And then let's complete the thing. Then you press the C button, and your expectation would be the display shows 0. Okay. Okay, that's the first automated test that we've implemented. Great. Every intermediate step we check and see if it results into something cool. Okay, so let's go on. Test number 2. What else would you test? Out of scope? If you press 2 plus plus and the whole thing explodes, that's okay. Out of scope.
Plus 2. Can you add more? Meaning you added 2 plus 2. Can you add plus 2? No. Continue.
No, the whole thing explodes as well. So this is the only sequence, and then you can restart here. 22 is... 22, it's a 2 plus 2 calculator, not the 22 plus 2 calculator, that's in iteration 17.
You check that the result is displayed for a certain period of time until you press anything? That it's aligned in the correct order? I mean, it's on your right, not on the left, not in the middle?
Certain is not computable. If you tell the computer, check that it's there for a certain...
It's aligned on your right, the first digit on the right?
No, but the duration, how long?
Certain
is...
Yeah, so Until the, okay, so we have unlimited power, so,
42?
so for unlimited time.
42 seconds at least. More than 42 seconds. Right? Good. Okay, test number 3.
Do and reset.
Sorry?
Do and reset.
Let's go.
That the result is actually visible under some amount of light.
How much? I'm a computer, you need to tell me.
It's Candela or whatever, not a physicist.
I think lumen
You should consult someone, yeah.
at 42 lumen. So, okay. I have no idea how much it is, but okay, 42 sounds good. Yeah. Okay, test number 4.
Do plus equal.
No, let's go. It's the only sequence you're allowed to do is 2 plus 2 equals and then C again. And then you restart from the beginning.
How many times can you do that?
How many times?
Performance, I guess, yeah.
Okay.
How many times?
How many times do you want?
200 million.
200 million. 200 million times. Repeat. Okay, good.
Because you check the amount of time that it passes until you get the result.
Time to result.
Also, the
Smaller than how much?
If it's automated, I guess half a second.
Okay.
durability of buttons.
Sorry, over there.
Durability of buttons.
The reliability of the buttons.
Yeah, I mean, let's say 1 million of pressings on the buttons, on each of the buttons.
1 million presses. Okay.
Yeah.
Well,
So
you have to go through the sequence.
Quality thing.
We have that here. So this we can actually make test for A and for B. One is kind of result, and the other one that the buttons don't melt away. buttons still intact. Okay, cool.
Press buttons very hard.
Yeah, that's. I think
Oh,
we
that's
can,
the
we can
same?
inject that in here. Yeah. Good. Okay, good test.
We switched it on, but is it possible to switch it off?
Oscilloscope. You know, if you can't be
Work underwater.
on the water, that's oscilloscope.
Work while attached on a rocket.
While attached on a rocket. What, can you explain? What do you?
GPS doesn't work if it moves too fast.
It has no GPS in there.
Yeah, but maybe it doesn't work either.
Aha, so you accelerate it. You want to accelerate and see whether or not it works in high speed. Well,
Attached to a rocket.
I think the closer you get to C, which is the concept for lights,
No, the
speed,
button. See.
and probably kind of it starts to expand and all sorts of weird things. Yeah.
Yeah, you would need to know the use case actually, what it would be used for, then you can maybe think more.
The use case is I'm a calculator needing person and want to know what 2 plus 2 equals.
What will you calculate under what conditions?
2 plus 2.
Where? Physical location, yeah, environment. What will you calculate?
With kids, this is not for kids, it's too small, it can be swallowed, and then there are other problems than the correct result. Okay, but can we say now we have kind of a full set of tests and we can actually prove that, okay, there is no problem with 2 plus 2?
No.
No?
There's never enough.
Never enough? Yeah. This is like the same answer as it depends, and they're not saying what it depends on.
It depends on how fat are your fingers.
How fast?
How fat.
How fat?
Yeah, you might not be able to press the button.
Okay, so it has been calibrated towards the fattest person on the planet in order to humanity. So
Are you strong enough to push such a big button?
there you go. But do we miss something here? So let's say that that's good enough to prove that 2 plus 2 equals 4 and everything is correct. Okay, so let's see, I'm a test engineer and I just go a little bit deeper and see in the inside. And then I notice, okay, the calculation that happens inside is 2 times 2 and not 2 plus 2. So this will result in a problem as soon as we have the next iteration, which is a 3 plus 3 calculator, which will display 9 instead of 6. Would you report this as a bug? No. So you discover that the calculation 2 plus 2 is actually not 2 plus 2, but 2 times 2.
It's out of scope.
Do we have? I'm the guy who says what's out of scope. Great. No, so okay, would you report it as a bug? Now be reasonable, come on. Yes. Okay, bug.
You won't be able to find that bug since there's no multiply sign on the calculator.
No, you just go into the code. You kind of check the code inside the calculator, and then you discover that.
So if you say that computer does multiplications by adding up,
No, it doesn't, of course. That's not going
that's going to be a bug also.
Yeah.
But that can be a feature.
Yeah. You know, every bug is a feature for someone. Security vulnerabilities are huge features for crackers and hackers. Great features. Okay, so you press 2 + 2 equals sign, and then you get a 4 here, but you get as an additional declaration, you get a 5 displayed on the left side of the display. Would you report that as a bug? Yes, okay, so we have another test to add. Okay, so you press 2 + 2 equals sign, and the whole thing gets incredibly hot and you have to drop it because you burn your hands. Would you report that as a bug? Yes, of course. So what I want to say here is that even in this very, very simple example, we can't have 100% coverage. This 100% coverage was also what David mentioned in his keynote. It's always according to a model, and it's even in this very simple thing, you will always find a point where the whole thing fails and where you would have to report a bug. Now what's happening here is that when we came up with all the tests, you gave me all your explicit knowledge, everything that you could think of. But then when I mentioned these kind of special cases, you immediately recognize, okay, we have a problem here, that's a bug. So what happens there is that this was a violation of your implicit expectations. So if you had to come up with a list of everything that can go wrong in this room, and we brainstorm, we do it for 3 hours, you'll probably have a huge list. Now I give you a case. There is a cargo plane, the door opens, and a circus elephant drops, and it actually comes through the roof. I would bet a lot of money that this wouldn't have been on anyone's list, but you would immediately recognize that this is something that can go wrong in this room. So the space of violations of implicit expectations is so much bigger than your explicit expectations that you can actually formulate. And as a tester, you need to be aware of that, that the application not only has a set of things it should do, but also a huge list of things it shouldn't do. And the second part is much more tricky. Cool, so what is software testing to me? David said also that one part of testing is to convey confidence, and I agree with that often testing leads to greater confidence in the product. But I also say that it often destroys confidence. You all had this kind of, yes, it will be all right, and then suddenly testers come along and they find a lot of bugs, which creates a lot of uncertainty with people. So it's actually a little bit of both. But to me, testing is to provide quality-related information about the product efficiently to stakeholders. So again, David is here? Is David here? Yeah. Oh, over there, yeah. So I like the way you put it, that it is evidence that you're collecting, because that's a nicer, more concise form of what I just call information. So information is broader than evidence, and I'm probably going to steal that from you, and then refer.
That's fine, Ilari. Just to clarify the previous point, I was talking about confidence in our decisions regarding the software, not confidence in the software itself. Hence, I can be confident it's bad, and still more confidence.
Okay, so you can confidently express uncertainty
Yes,
and in comfort. Okay, cool, good. Okay, so as I started before, there are these two areas of testing. One is just to confirm whether your expectations that you can formulate explicitly are correct. And the other one is just experimentation. It's the exploration of a product, which will reveal things you didn't even know that you did not know. So you know all Rumsfeld with the unknown unknowns, and that's where testing is located a lot. So the checking part is very often the part that can be automated, because basically you can let an algorithm decide whether or not your expectation is correct or is violated. So that's the easy part. Experimentation is often much more difficult, because there is an infinite set of experiments that you can run with any software. Now, how to decide that? And it also goes into the test design part, how to do that. So this is also from James Bach and Michael Bolton. So they actually call it checking versus testing, but I don't see these as equal things because testing is the whole thing. Whereas I think testing consists of doing checks with confirming or refuting explicit expectations, and experimentation where you don't know yet what's going to happen, but you can evaluate the outcome. And the outcome either violates your implicit expectations or it doesn't. So it gives you a couple of information. So again, the level of testing is quite an important area. So you need to be aware of what is helpful in what area. So a unit test can't give you any information about how a system as a whole functions, especially because the system of software is not a technological one, it's a human technological one. Software is operated by humans in most cases, not always, but mostly humans are also part of software because they operate it. And we humans are a big mess, and so it's not something that is easily foreseeable. So there's the Ashby's law of requisite variety, which basically says that if you want to control a system, your control system needs to be needs to have higher variety than the system that you're testing. So basically, unit tests can't give you systemic input. That's one of my favorite ones. Manual testing. Who's a manual tester in here? Okay. So, who are the developers? Okay. So, the developers, are you manual developers or are you automated developers? Or are you? You're a developer. Are you manual?
I'm a tester, but also
Oh, you're a tester.
developing, so.
Okay, but you're a manual developer?
No, this depends.
On what?
What we agree to call manual.
Okay, excellent answer. So it depends on how you call it. That's fine. Now the trouble there is with developers. I mean, I observe developers sometimes. I just sneak over their shoulders, and what I see is their hands. Their hands are doing handiwork on the keyboard. So it's a highly manual thing, right? So basically, developing a big application is the same thing as shoveling a piece of sand from one area to the other and then back again, right? So it's the same quality of work. Now it's more the manual thing gives the impression of, okay, that's an unskilled activity. Manual testers are the ones that are unschooled and just taken from the street and yeah, you just tell them what they're supposed to do. I believe that manual tester conveys an image of unskilled, and that's not right, because as in software development, the organ that is mostly involved is not the hands, it's the brain. So our brain is the important thing. So it's brain testing, I don't know how to call it. I would just declare it as there is a degree of interactivity, human interactivity with the system, and it's on a scale. So you can't really manipulate bits in a computer. So if you can't do that, it's kind of you're a scary person. So, but no one can. You always use a little bit of automation. One is your mouse driver, the other one is your keyboard driver. So there's no such thing as kind of really going into the code and manipulating it with your hands. That's not what you do. But there is a degree of interactivity you do with the product. So either you're present as a tester and you interact with the product you're testing, or it's a machine that does it overnight and then delivers you the result. But then again, it's a human who needs to make sense of the results. So automation can't give you this certainty of, okay, everything is fine. Let's say you come in the morning, you have a regression suite that always has a couple of failing tests and it's here and there, and then in the morning you come in and everything is green. It's going to be, first suspicion is, this is weird, let's look at it. The same thing applies if everything is red. Your first assumption is not, okay, oh, we really messed up here. Your first assumption is we probably have a problem with the test environment, and just, the build wasn't available or something like that. So it's you as a sense-making machine that is important. And so I would like to remove the label manual tester and just call testers. I don't see a need for automation tester or tester. Cool. So a couple of fundamentals. This is very nice because software testing is not complicated. Well, it is. It can be sometimes complicated, but what I believe is that it kind of misses the point. I've come across Dave Snowden's Kinefin model recently, and I think it has a high applicability to software testers in general. It categorizes system according to how they behave. So there are simple or obvious systems that are very easy. So if you have to calculate 1 + 1, that's a very simple system, and it can be solved algorithmically. So basically you just apply a specific rule. 1 + 1 is the addition rule. It results in 2 every single time. It's a very simple thing to do. Then you have complicated systems. So let's say a long mathematical formula can be highly complicated because you really need to analyze it in order to be able to solve the whole thing. And you can't do that very quickly. So it needs a lot of analysis, but the analysis will, in an ideal case, lead to the same result every single time. Now, complex systems are different. Complex systems behave in a way that is not foreseeable 100%, and also doesn't lead to the same result every single time. There are very simple complex systems. One of these are, for instance, roundabouts. Roundabout, you mostly have 4 entry and exit points. It goes counterclockwise, and there are cars. Now, if you inject more and more cars, it starts to become slower or faster, and you can't really foresee exactly what's going to happen because every single car seats a human. Well, up to now, maybe in the future that's no longer the case, but up to now there's a human who makes a decision. And you can't really analyze that system and tell, okay, if we have 300 cars an hour, that's how the system will behave exactly. The same applies to a street where there is a traffic jam. So usually what happens is someone brakes a little bit, and then that propagates into a system that brings the whole street to a halt if the throughput of cars reaches a certain threshold. But you can't see that. Now, software testing, since we operate with a deterministic machine that is operated by irrational humans, we, by definition, have a complex system. We never know what's exactly going to happen. So many of these certification people and the standardization people think that testing is just a complicated problem, something that you need to analyze and over-document, and then you'll be fine. Whereby completely missing the point that it is not a complicated system in its heart, it's a complex system. And you approach complex systems in a different way, which means that you often go for experimentation and you see, okay, what works? And then if something works, you will go on with that. If it doesn't work, you try something else. But if you have these standardized procedures that you just apply to every single testing project, you will be in a big mess. Okay, so what do you think is the most important quality of a software tester? What's the most important skill? Creativity, yeah. Curiosity, yeah. All of the above? That's nice. Okay. Something else?
Maybe communication, being able to communicate.
Communication, yeah. So who works in large companies, meaning kind of more than, say, 2,000 people? How are your processes? Okay, yeah, so just kind of this uncomfortable laughter. That's, yeah, exactly. So communication is a super important thing. We with House of Test, we're currently with a big client, and they have a huge mess. So I can really draw that they have. So communication, I think, is a very good one. So I just simplify it a lot. These are the directions. This is the managerial structure of that company. So as you can see, a very big mess. So people are kind of not clear what their role is. In order to entangle that, I think the communication capabilities are super important. Yeah. So in my life as manager, I've interviewed a lot of testing. So one area that I believe is often lacking is the ability to think in abstract terms, kind of to build models and make them more abstract. I think that is super important as a tester, that you can actually build a model and use that model to test something. Then that's also the age-old question. So since we still classify manual and automated testers into 2 different categories, what should be the level of someone who has not a technical background? There is a guy called Harry Collins. He's a professor in Wales, I think, and he has come up with the term interactive expertise. So interactive expertise is a skill level which allows you to have a meaningful discussion with an expert in that area. So if I had to speak to, let's say, a physicist, I'm not a physicist, I would probably be a little bit lower on the expertise, interactional expertise level. I couldn't have a meaningful discussion with a physicist on kind of this little particle things. But I believe as a tester, one should at least achieve a level of interactive expertise in technical matters. And if you don't have that, try to achieve it. That's one thing, coherent writer and note taker. Who takes notes while testing? Who has a notebook and takes notes? Yeah. Do you find that useful in order to structure your thinking? Yeah, sometimes kind of writing down things, then you can read your own thinking. That allows you to do that. It's certainly a good idea to become a very coherent writer and note taker in order to convey information both to others and to oneself. Here he has championing curiosity. So it's a good idea to consult the masters in curiosity when you want to learn that. Who are the masters of curiosity? Children. Yeah, so if you have kids, just try to go from A to B and let your kid define the speed of getting. You will never get to B. Especially if you have, say, a 4 or 5 year old, you will never get anywhere. Because they're so curious, they see a crack somewhere and that becomes suddenly interesting, or there's a snail you have completely missed. So I think kids are great masters in teaching us in curiosity.
Unless ice-cream is waiting at me.
Well, yes, there are a couple of tricks you can apply. So in order to speed it up, yeah, kind of bribe them. Bribery is a known method. Very good. You know what another method is? If your kid doesn't want, oh, sorry, I diverge a little bit. If your kid doesn't want to do what you want to do, and you tell them, do this, then just wait 30 seconds and ask again. Sometimes it's just not the right moment at this point, but 30 seconds later is perfectly okay. Just try this once, it's great. It's fantastic. Good, so precision and accuracy, I think these are super important categories of a tester. I think all these dimensions should be something that you interview people for. Okay. A healthy sense of humor is certainly helpful, especially if you're in a highly bureaucratic organization where things look like this. And a sense of humor will actually keep you alive and make you kill yourself. Okay, so the last, so you can see, I think there is a progress bar. Yeah, we're almost at the end. So community thing. This is great. This conference here is great because it brings a lot of testers together. And what I would advise you is kind of to talk to each other as much as possible and talk about what you're doing in testing. Getting to know other people and building your network among testers is incredibly helpful in advancing your own learning in testing. So if you reach out to people and come to conferences, that is very helpful. So, of course, I need to mention that. So the Association for Software Testing, it's a great organization that advocates for good testing in the world. We're active all across the world, and we also offer a couple of education tracks that might be of interest to you. And if someone is interested, then just look out for me and I can give you more information on the AST. Twitter is fun because people shout at each other. That's great and it's very constructive. No, but it's also something where a lot of information in the testing scene gets advertised. So on Twitter you'll find conferences that are happening or specific meetups. There's a lot of things you can do over Twitter. Then of course, conferences and meetups. If you don't find your meetup, then just found your own one. So there is this platform, meetup.com, which I find it very great because it almost costs nothing and it allows you to organize a meetup of testers. So I highly recommend to build your own meetup on testers. That will invite people who are also interested in testing to come and you can have meaningful discussions. Then, of course, conferences like this one here. This is great, 600 people, that's absolutely amazing. I think that's a good way to get input for that. There's a whole lot of testing blogs. If someone is interested, I have a whole list of things that I find useful. That doesn't mean that this is universally useful. And I can give you a list of that as well. We have how much time more?
4 minutes.
5 minutes. Okay, good. So, education. As I mentioned before, it's very difficult to study software engineering, software testing at the university, and then there are all these certifications. There are very few things that you can do on the side that I'm aware of in terms of testing that is not specifically in the technical area. So the BBSD class is called Black Box Software Testing. These are 4-week courses offered by the Association for Software Testing, or also by Alton, which is a Romanian company. So they offer these courses. They're 4 weeks. They are very hard time-wise because you have to calculate about 15 to 20 hours a week of work. You collaborate with about 20 other people that are spread across the globe, and you will have to do some project work during these 4 weeks, and it gives you a really deep immersion into the subject of software testing. And there are currently 3 courses available. There's a foundation level, and there is one on test design and one on bug advocacy or bug reporting. That's very good. Rapid software testing is certainly something that can be of interest. If you see James Bach or Michael Bolton holding these, it's a 3-day course that will energize you for testing. It doesn't give you practical thing for your day-to-day work, but it will energize you for testing and see things in a different way. Okay, cool. So what do I believe is helpful? So constant learning, just go on your learning track, that's good. Consider via negativa. I think that's a religious term of not doing something. It is good to know what you shouldn't do and be aware of that and then refrain from doing it. Then also for testing, I think it is not pure engineering, but it is philosophy plus engineering. That's what makes software testing or building software, or the whole software development industry so interesting a field to be in. And then build your community, join a community, and do it like that. Cool. So, do you have questions? Objections? Complaints?
I don't have a question.
Yep.
I completely agree with you, but just in order to break the silence, I would like to add maybe empathy to one of the key skills for a tester, to be able to stand into developer shoes, into end user shoes, into manager shoes, and to understand from different perspectives. So I would think that's also a good skill to have.
Empathy,
Yeah.
absolutely. I'm sure you have come across these people who see the developer as the enemy, and it's kind of the antichrist. These are, the evil people over there. It's in one of our projects we have such a person. He doesn't work for House of Pest and will never in his whole life. But that person thinks exactly that. Oh, these are just evil people, and he also kind of lets it know. So it's your non-verbal cues will give it away. So he really thinks they are just stupid and they do stupid work, and he has absolutely no empathy for them, and I think that's harmful. So I agree with you, empathy certainly.
I would say that this point is not in our scope.
Why? Why not?
Next iteration.
No, I honestly think empathy is definitely in our scope to as a quality that we should foster. Yeah. Okay. Any more?
I wanted to ask about certification.
Yep.
We said that we don't ask the surgeons or pilots to test for answers or something. Do you think that if something would change that in certifications, there would be open questions? There would still be people who would go to 3-day course and think, okay, now I understand everything and go take the test. Does it really depend on the form of the examination, or does it depend actually on the person who is taking the test or exam or whatever?
First of all, the reason why there are no open questions is that it doesn't scale. And it makes the whole endeavor much more expensive and the profit of that much lower. So you need far more people to help with that. The multiple choice, you can machine evaluate them. It's very easy. Whereas for open questions, someone needs to read that and evaluate. But certainly I agree with you, if there were open questions where you really have to go into an essay form and explain your reasoning, that would have more value. When I said that medical doctors don't do these kind of question and answer, they actually do. I think in the first couple of years of medicine, you have to memorize all the body parts and the organs and everything. And it's a very tiring exercise. But it goes on with that, because afterwards, as soon as they have graduated at the university, they will go to a hospital and do an apprentice. It's not called apprenticeship, it's a kind of internship where they work as a junior doctor for many, many years until they can make their own decisions. And so they really apply their skill. So there's a difference between knowing about something and knowing how to do things. And the other one is the applied skill. I think that's much more important in testing than being able to give a definition of what a test report is.
I just want to add that I think that PBST courses have exactly the same good approach of testing and how they do that. They exactly like focus on reporting, getting and receiving feedback. So these are very nice way of certification.
Okay. Have you done PBST? Yeah. Okay. Great. Yeah. So can you recommend it?
Yeah, of course. That's one must have. I think they somewhat like bunch of things together. You don't like when you now like learn these things, you understand that they are pretty much covered in some kind of a more abstract way, but they are covered in this PBST courses.
Right. Yeah. Cool. Okay.
So
thanks a lot.
thank you very much.
Thanks a lot. Oh,
Okay,
yeah.
the last
One
one.
last.
I also did BBST and I really recommend that it depends on your context and what you're doing in your own company.
You can actually do that. The material is Creative Commons, so all the BBST material is not owned, so you can use it. You just need to make a reference to the originators, but you can actually use it and do it in your company.
No, I meant that BBST's value really depends on the context of your company, because for us, majority of BBST's content was just not applicable.
Okay.
So there's really some thought taken for BBST.
Okay, cool. That's another view. Okay, thanks a lot for coming.
Thank you very much.